Hello and welcome. This is Dr. Hadi and the channel is The Medical World. Welcome to the medical world. Today's topic is protein. We will discuss protein in different lectures because protein topic is complicated and lengthy. We cannot record the whole protein in single one lecture because we need more time. So we will divide the whole protein in different segments. Accordingly, each segment will be recorded separately. So come to the first segment of the protein. Starting from the definition of the protein. First of all, before definition of protein, we will come to the history, why the name protein comes here, why that compound was called as protein. Actually, this word comes from a Greek word proteos, and proteos means something very important, something which holds the first place. So holding the first place, or we say something which is very important. And protein is among those organic compounds which play an important role in not only the human body but every living body in the world, every living body. The protein is playing a great role, a very important role. That is why they were called as the something that hold first place. Even later on, other scientists, they called that these proteins were named protein because they were the high molecular weight compound, and these were present in abundance in animals and other organisms. That is why they were called as protein. So the first name of proteose was prime importance, something very important and something holding the first place. Now come to the definition of protein. What are proteins, or what is protein? A protein is a polymer. Now here is a word polymer. What is polymer first? A polymer is something which is made by the combination of smaller units. Let's suppose we have these smaller units, and if I combine these units together, and we will get a polymer, right? So in organic chemistry and in biochemistry, you will hear this word polymer repeatedly again and again. That's why you must learn what is polymer first. A polymer is a compound, a large molecule that is made by the combination of small molecules or smaller units. For the convenience and for the simplicity, I am going to write the units in the form of a circle. Each of this circle will represent different molecule compound in the future videos and lectures. Today, because we are learning protein, so in case of protein, these smaller units will be given a name of amino acids. If I write it completely, amino acid. So we say a protein is made up of large number of smaller units called amino acids. Maybe 2 amino acids combined, 3 amino acids combined, 100 and 1000. So many amino acids, when they combine, will give us a protein. So a protein has the building block. A simplest unit of protein is the amino acid. So now the question arises in the mind of a student, what is amino acid? Because if we are able to learn the basic unit, we will definitely be able to understand the whole protein. So let's come to the amino acids. What is an amino acid? An amino acid is a compound. Compounds are different, inorganic and organic. Amino acid is an organic compound that contain a central atom carbon, and that carbon is called as alpha carbon. Alpha, this sign is for alpha, this is called as alpha carbon, and around this carbon you will find 4 groups are attached. The first group is called COOH. We call it carboxylic group. And the second one is NH2. We call it the amino group. Carboxylic group and amino group, these two are actually functional groups, and someday you will be provided the lecture on the functional group as well, especially when I will record the lecture on carbohydrate. Definitely you would be given some idea about the functional groups. So here we have functional group carboxylic acid and amino group. These two functional groups are always present in amino acid, and these both groups are attached to the central carbon called alpha carbon. Remember, alpha carbon is given the name alpha because the carbon of the functional group, look at that, this is a functional group. If I say FG, that is your functional group. So the carbon of the functional group, after that carbon, any carbon which comes first will be given the name alpha, and then beta and gamma and so on. So that is why, because it comes after the functional group carbon, so hence it is called as alpha carbon. Above this alpha carbon there is a hydrogen atom, and below this carbon there is a variable group R. R is called a variable group. Why it is called a variable group? Because this R can be any compound from a simple hydrogen to a 1 carbon compound to a 2 carbon compound. That is why we write here R means variable group. Any atom or group can come here. Accordingly, different amino acids will come to us. It means that if there are more than one amino acids, each amino acid will be different from another amino acid with respect to this R group. If you find 3 amino acids, they may contain same COH group, NH2 and hydrogen, but these 3 amino acids would be different in respect to R. So that is very important group. We can give names and identification to every amino acid according to the R. Let's suppose, for example, if in place of this R, if hydrogen comes, let's suppose, if hydrogen comes here, so the name of that amino acid will be called as glycine. And if in place of R we get CH3 means methyl group, here if it comes methyl group, then that whole amino acid will be changed and the name will be called as alanine. So at least in today's lecture we have learned 2 types of amino acids. One was glycine and another was alanine. But notice one thing, that in all amino acids, there are different amino acids. Later on we will discuss this. In different amino acids, these 2 groups are most important. There will be no change in these 2 groups. These 2 groups will be there definitely, absolutely. These 2 groups will be present along with that hydrogen. But the only thing that may be differ from one amino acid to other amino acid would be that R group. As I discussed, that here hydrogen can come, here methyl can come, here a 3 carbon compound can come, here a benzene ring can come, here any other compound can take place, can occupy this position. So accordingly we will give the name to the amino acids. Now one thing more, the discovery of amino acid, just for the sake of your interest, the first amino acid was discovered in 1806. That name was called asparagine, And the second amino acid, threonine, threonin, threonine was discovered in 1938, almost 100 years later on. In between that duration, other amino acids were also discovered, and today we say that there are more than 100, and in some books more than 70 amino acids, but we are not concerned with all those amino acids. We are concerned with only 20 amino acids. Being for medical students, we are concerned with the 20 amino acids. So we usually say that there are 20 amino acids. Yes, they are right, but there are more than 20 amino acids as well. These 20 amino acids are those amino acids which are the part of the body constituent, the part of the body, like your muscle, like your hair, like your skin. So these are present over there. That is why they are only 20 amino acids, and we can also call it standard amino acids, right? There are other amino acids also that are not coded, that does not come from DNA. And remember, this is a wonderful difference to identify the two types of amino acids. One we call the 20 or standard amino acids. These 20 amino acids are come to us by the order of the DNA. DNA contain the codes. If you don't know about DNA, a lecture would come to you on the DNA as well. But I hope you people know the DNA. DNA is our genetic material. These 20 amino acids are ordered according to the DNA. These 20 amino acids code are present in the DNA, so they are standard amino acids. Other amino acids, although they have different structure, but still they are called amino acid because they have this basic structure. But as they do not come from the DNA, they have some role in our body. They play some role in our body. We will not count those amino acids here among these 20 amino acids. Okay, one more thing that I would compare the amino acids with alphabet. As you know that I'm going to erase it, right? Because you can pause the video and you can check it. If you see the alphabets, look at that. We have A, B, C, D, E, F, G, and so on, right? You can make different words by the combination of two or more than two alphabets, right? Let's suppose take D, E, A, and F. You just took 4 alphabets and you combine them, you got a word deaf, right? And you can take more words, combine them in different manner, in different style, you will get different words, right? This is so simple. But similarly, we have different amino acids. This is one amino acid and this is another amino acid. For simplicity, I am going to write ABC. So we have another amino acid X, another amino acid Z, next amino acid Y, and next amino acid F. You can combine these amino acids in different fashion. You will get different proteins. You will get different protein, right? Different proteins. And these different proteins are important for the body. These different proteins will serve inside your body. These different protein will serve something very special in your body. For example, these different protein will be presented in our body in the form of enzyme. Wow, enzyme is holding a very important place in biochemistry. Hormones, not all but some hormones are protein, and we have antibodies, we have hemoglobin, we have so many different proteins inside our body that are working, and they are working they are doing some very special task. They are doing some very special duties inside our body in the form of these. And look at that, enzyme, hormones, antibodies, and hemoglobin, these all come from us because of these protein, and these all are different proteins. All these different proteins come from the amino acids, only the 20 amino acids. So because of these reasons, we give the title prime importance, something very important, something holding the first place. Because of these two reasons. If we remove enzyme from body, the life is almost impossible. Hormones, antibodies, they are playing great role. They are playing a tremendous role in our body. That is why the protein deserves such a good name of proteose, something very important. Okay, and now once again, the next topic, which is called as the chiral center and chiral center or asymmetric carbon. I'm going to write another word which is called as asymmetric carbon. Asymmetric carbon, asymmetric carbon, right? What is this? A carbon atom to which 4 different groups are attached, A, B, C, D. Such carbon is called asymmetric carbon atom. If 2 groups are similar, that will not be called asymmetric carbon atom. Similarly, in amino acid, we saw that in amino acid there is a alpha carbon, and around that alpha carbon we got different groups, COH different group, NH2 amino different group, hydrogen different thing, different atom. Here anything could come, or let's suppose I write here CH3. Such this kind of amino acid where there are 4 different groups attached to the carbon, to the central carbon, we call it asymmetric carbon, and this is also called as chiral molecule. Or some people call it chiral molecule. Whatever you like, you are free to say chiral or chiral word. So this whole molecule become chiral molecule, and that center is called as chiral center or chiral center. Why this is more important, that chiral center? Because some of the properties of the molecules are related to that chiral center. Let's suppose if I say that there is a optical activity is a topic, optical activity. It is a wonderful topic, optical activity. What is that? In optical activity, what do? We have a solution here. We have a solution here, right? There is a solution. Okay. And we pass light through that solution. And here is light. Okay, we pass that light. Look at that. The light either rotate towards the right, or either it is rotated towards the left side. This property is called optical activity. Optical means light, optical activity. Those compounds which rotate the light, especially the plane polarized light, towards right or left. What is plane polarized light? A light usually diverges in different directions, the ordinary light we have. Such a light that travels in one specific direction is called as the plane polarized light. So when we pass the plane polarized light through that solution, it will be either rotated towards right or left, and we will call that solution shows some optical activity. And what is the cause of this optical activity? If a compound show optical activity, is because of that chiral center, that chiral carbon, that asymmetric carbon. So if the 2 groups are not different, all four groups are not different, that will not be a chiral center, that would not show the optical activity. Hence, that is very important to know that this is chiral molecule and that carbon is called asymmetric carbon. So where is asymmetric carbon? There will be chiral molecule. One thing more with that chiral molecule is L and D amino acids. What is L and D amino acid? Actually, we have a compound in carbohydrate. In carbohydrate, we have a compound what is called as glyceraldehyde, where there is 3 carbon atoms, 1, 2, 3 carbon atoms, and the first carbon have a CHO group and C double bond O and H here, right? And here is OH, H and H2OH, right? This is a 3 carbon compound, a 3 carbon sugar, and we call it glyceraldehyde. Okay, this is a sugar, this is a monosaccharide, which is not the part of today's protein lecture, but we have to revise it as again. That topic belongs to carbohydrate. The scientist came, they selected among all these sugar monosaccharide, they selected this one, glyceraldehyde, to compare that compound with other compounds, and hence this was called as reference sugar. Reference sugar, because we will compare other compounds with that. Why we compare other compounds with that? Because in other compounds we have the H and OH either on the right or on the left side. So some compounds we have, let's suppose A, B, C, we have a compound. Here the H is on the right side and the OH is on the left side. Here the H is on the right side and the OH is on the left side. So if we want to compare this with this one, so how we will give a name to this? We must give them some name. Although these compounds are very similar, let's suppose here is H and OH. Here is another compound C. Okay, sorry, A, B, C, A, B, and C. Okay, here is H and OH. Here is OH and H, and here is OH and again H. These two compounds are quite similar compounds, but they are only different with respect to the hydrogen and OH on the right, or either on the right or left side. What name would you give to these two compounds? These two compounds are absolutely very similar. So we must give them some name. We must give them some name. So here the word come L and D concept. L and D concept. Actually, this belongs to a topic called stereoisomer. Stereoisomer are those compounds which have the same molecular formula, the same structural formula, but they only differ with respect to the OH groups, the configuration of the OH group. Configuration means if this is the central line, the OH may be on the right side or on the left side or on the back side or on the front side. We called it the three-dimensional study of compounds. Three-dimensional study. So the stereoisomers are differ from one another with respect to the OH group on the right side or on the left side. Let's suppose these two have same structure formula, same number of atoms, but they are stereoisomers. Why? Because they differ from one another with respect to the configuration. Configuration means space in space. So the H, OH are differ with respect to the space, and here is OH and OH are differ with respect to space. So we call them stereoisomers. Inside the stereoisomers, we use another word which is called as enantiomer. Enantiomer. Enantiomer is a type of stereoisomer. What type of stereoisomer? If the two compounds are the mirror image of each other or the non-superimposable. Non-superimposable means that just like you have your right hand and here you have your left hand, just like your right and left hand can never be superimposed. They are different from one another. So we have some compounds that are related to each other, similar to your right and left hand, but their position is just like your right and left hand, that are non-superimposable. Look at that. Here the thumb is on the right side, but here the thumb is on my left side. So such compounds which are just like your left and right hand, such compounds which have the symmetry or non-superimposable image. This word non-superimposable image is more important. How I would like to tell you, if I place a mirror here, and that is a compound that you will place in front of the mirror. So inside the mirror, that compound will be shown like this. The OH is on the right, but here the OH will be shown on the left, because this compound is original. Let's suppose original, and this is the mirror image. If you see this compound in a mirror, you will see like this. The OH on the right, but this OH is on the left. The H is on the right, but here is on the left, and here is on the right, but here is on the left. Such two compounds which are just a mirror image of one another, we call them, of course they are stereoisomers, of course they are called as enantiomers. Such compounds, enantiomers, we will compare these compounds with the glyceraldehyde, because we already gave the title of reference sugar to the glyceraldehyde. So if in glyceraldehyde carbon number 1 and carbon number 2, right? This is carbon number 2. You will focus on carbon number 2. You will forget all other carbon. If on the carbon number 2, the OH is on the left side, we will give them L-glyceraldehyde. And if the OH is on the right side, on carbon number 2, you will give them the name D-glyceraldehyde. So glyceraldehyde is of two types, that L-glyceraldehyde and D-glyceraldehyde. Now any other compound, we are going to discuss some absolute configuration. Any other compound which have the OH on the right side, which OH? Remember, the carbon from the last carbon, means the second last carbon. So if there are 5 carbon, so you will focus on 4 carbon. If there are 6 carbon, you will focus on 5th carbon. So if 1, 2, 3rd, this is the last carbon, you will focus on that carbon. So you will only focus on the second last carbon, and then you will make some comparison. This compound, the second last, this one is the last. If this is the last, this is second last carbon. Here the OH is on the left side. So you will give them the name L compound, and here the OH is on the right side, so we will give them the name D. Don't look at that OH. We are not concerned with the last carbon OH. Whenever we are discuss L and D sugar, we will look at the second last carbon. Similarly, if we come to amino acid, in amino acid we have we don't have the OH group actually in amino acid, but something most important is that if you pass light through the amino acid, the light is rotated either to the right or left. It means amino acid also shows some optical activities. So what is the reason behind this? Even in amino acid we don't have direct OH attached to the carbon. So here other functional groups will be discussed. This is alpha carbon, and we will write now the amino acid slightly rotated in a rotated position. The COOH group, right, the NH2 group is here, and right here we give them, let's suppose here is hydrogen and here is CH3. right? Here, if you just see to that compound, you can focus CH3, either it is on the right side or on the left side. You can give them the L and D amino acid. And if we see that CH3 is in comparison to the OH group of the glyceraldehyde, so if CH3 comes on the right side, we will give them the name D amino acid, and if that CH3 comes on the left side, we will give them the name L amino acid. So it is not necessarily that we see some OH group, and if the OH group is on the right and left, then we will decide. No, we see that this is also carbon, this is also carbon, but this is the second last carbon. At that carbon, if we see the CH3 is on the right side, we will see the D amino acid, and if it is on the left side, we call it L amino acid. The good news is that inside the human body or other living body, all the amino acids are present in L form. Our body, they don't have this amino acid in D configurations. However, some of the amino acids in D configuration are found in some bacteria, but in the human body, all the amino acids are in L configuration, right? Now, the last but not the least is amino acid presentation. The student face some difficulty while drawing the structure of the amino acid. That is very, very simple. Don't worry about this. I'm going to tell you how to present amino acid. Amino acid presentation can be presented in two ways. One is called the perspective formula, and the other one is called as the projection formula. In perspective formula, we write this kind of shape, which is called wedge, W-E-D-G, solid. That is called solid wedge shape. Yes, this is called solid wedge shape. We write like this, and again, like this. This is again solid wedge shape. It is filled, and here we write like this. Okay, longer, a little bit shorter, more shorter, more, and more, right? In here, longer, shorter, and yeah, these are dotted lines, dashed lines. Sorry. What is mean by this dashed lines? These wedge means that the groups attached here are towards the reader. I am reader, you people are the reader. So these two groups are actually towards us. These two groups are like that. Yes, they are towards us. On the board, we can't write. So we draw like this. These two shapes shows that the groups are towards the reader, out of the plane. The board is the plane, and these two groups are out of the plane towards you. And the groups which are attached to the dashed lines means that these groups are away from the reader and towards the whiteboard or behind the plane, right? So if we say that here is COOH and here is NH2, so we say that the COH and NH2 groups are towards the reader, and here it comes hydrogen and CH3. So hydrogen and CH3 are towards the whiteboard, away from the reader. This kind of presentation is called as perspective formula. A student really feels some difficulty while drawing such kind of structures, as it will take some time. So we usually draw like this: carbon and COOH, here NH2. We just draw a line like this, and here is H and here is CH3. Here the horizontal lines represent, usually the horizontal lines are considered that the two groups are towards the reader. Whenever if the two groups are towards the reader, so we will write them horizontal lines, and if they are away from us, we'll give them the vertical lines. So horizontal lines on the board looks like that the COH is on that side, but actually the COH is towards us and the NH2 is towards us, and these H and CH3 are away from us. So that was the two presentation. One was the perspective presentation and the second one was the projection formula. I hope you understand the lecture. If not, you can repeat the lecture again and again. I hope you enjoyed and understand the lecture. Have a very fine, good, healthy smile on your face. Keep me remember in your prayers. We'll see you in the next video. Thank you, bye bye, and of course, tata.